Good morning, everyone. Thank you very much for being here today in our first showcase for the Community of Practice, Soil Information Community of Practice in Africa. Uh, we will have today three speakers, and the agenda for today is we will start with Dr. Ivona, and then Dr. Eli Mayo, and then we will have Professor Ibia presenting their latest research finding in two sessions. First, concerning the soil information, applying soil information, and the second is about laboratory analysis. Then we will have the second hour, sorry, for answering your questions. Thank you once again for taking part of this event, and we shall start now, and then we will expect more people to join. First presentation will be for our speaker, Dr. Ivona from Nigeria. Dr. Ivona, would you like to introduce yourself, and then feel free to share your screen. Thank you. Floor is yours.
Thank you, Crow. Good morning, everyone. Dr. Adalvi Yvonne Omoya, an Assistant Research Director at the National Biotechnology Development Agency in Abuja, Nigeria. So I'll be sharing part of my research findings with us today. Some aspects of the work have also been shared at a scientific forum. So I'll share this part with us and expect to learn more and give us better insight on what it is I've done in my research. So I'll go ahead and share my screen. So I consider it an honor to be presenting at this first Community of Practice Showcase event. As I've said earlier, I'm Dr. Omoya, and the title of my presentation today is Bioaccumulation Potentials of Indigenous Plants for Metals in Soils from North Central Nigeria. So being that most of us are well knowledgeable in soil and things around soil, so I'll just brief through the introduction. So bioaccumulation is simply the accumulation of chemicals in a living organisms, as we know. So usually these chemicals, which we often refer to as contaminants when they occur in high concentrations or concentrations that are considered dangerous to the organism. Usually these contaminants enter into the organisms via soil, water, air, or through dietary intake. And one of the sources of this contamination, as we have reported in by different researchers, is mining. And we know that mining activities exert an incredible burden on local fauna and flora. So usually the processes involved in mining leads to discharge of enormous amounts of toxic effluents into the environment. So on this slide, we have the figure one, just showing us a pathway through which heavy metals or contaminants enter into the food cycle and then get absorbed by humans. So we see that usually contaminants potentially enter the food chain through bioaccumulation and assimilation, thus affecting human and animal health. Bioaccumulation is therefore an important consideration in the regulation and treatment of metals associated with acid mine drainage. So it is for this reason that we went into this research, and I forgot to mention earlier, it's a research that I did with my team of supervisors, as you saw on the opening slide. So the objectives of this research was to identify indigenous plants that could be utilized for restoration of metal-contaminated soils in mining sites located in north-central Nigeria. In Nigeria, we have 6 regions, and one of them is the north-central region. My sample location was from the north-central Nigeria, and then our objectives was to determine the metal concentration of the plant samples and compare them with established standards, then to as well determine their bioaccumulation factor and suggest through this the plants that could be used for restoration of contaminated sites. So like I said earlier, my my sample collection was done in Nasarawa State, which is a state located in the north-central region of the country. So my samples, the plant samples were collected in situ. It was basically plants that were seen on site that were collected. This method was used because of the sparse vegetation in most of these locations, because there are locations that where people have been involved in mining, both at large scale level and artisanal level. So out of the 13 local governments in Nasarawa State, I collected samples from 6 of the local governments. And these sites I picked based on accessibility and then due to the security challenges around there. So I had to restrict myself to those 6 local governments. So this a general overview of metals of resources that are mined in Nasarawa State. Actually, Nasarawa State is known as the home of solid minerals in Nigeria. So we see the 13 local governments, and then we see the minerals that are found in those local governments. So as I said earlier, out of the 13, I worked on 6 local governments. So for this study, the transfer factor, which is the bioaccumulation factor, was calculated as the ratio of metal concentration in above ground tissue of the plants to the corresponding level in the soil. So this was what I used to arrive at the transfer coefficient, which also is the bioaccumulation factor. So this figure is showing us a stacked representation in percentage of the concentrations of different metals, the average concentration of different metals in the different sites. So 9 sites were considered for the study. And then this is a representation of the average concentration of metals in them. And these values were compared with the WHO limits and the normal range of metals in plants as documented by Hajar et al. 2014. From this table, we see that mostly the manganese, which is the orange part, the copper, this, and zinc concentration, the average manganese, copper, and zinc concentrations for all the plants exceeded the WHO limits and the normal range of metals in plants. So going further, we also know that metals such as chromium, cobalt, and lead have low coefficients because they are usually strongly bound to the soil colloids. Studies have reported that, and this study, Ogbonna et al. As well agrees with this statement. And we see that the low TC values for lead in a zinc-lead mining site at Isiagu was also reported by Ogbonna et al. So the same trend was observed in this study for most of the locations studied, except in 4 of the sites. And these 4 sites, in these 4 sites, lead concentration exceeded the normal range of metals in plants. These sites are actually sites that are related to lead zinc deposits. So it is not a surprise that they have plants that are able to take up these metals in larger quantities than others. So this is just a correlation table, and we see also a strong relationship between the occurrence of lithium and lead. We see also a very strong relationship between cobalt and lead. And we have other few situations where there are some metals are strongly related to each other, like we have cadmium and cobalt as well, having a strong relationship, a significant relationship. So this figure is showing us is a summary of the transfer coefficients of metal in the different locations by location. And we see here that here we're showing how the plants were able to accumulate the different metals. And we see that some plants are able to accumulate arsenic, as if you follow the key that is given. So some plants as well showed great, we see the siam weed here, showing great potential for assimilating cadmium here in this site. And this particular site is a lead zinc mining site. And this siam weed, it's a common weed seen around the country, and it's supposed to be an indicator of contamination of certain metals. So we also see that share nut tree here has high values for TC. And this is in a copper mining site as well. So we see that it can accumulate zinc in high quantities. So this is a contribution of the accumulation to give us a picture of what it is. So we see here that for selenium, there is no much difference among the 3 plants here listed, but we see that the camel foot tree has a high level of accumulation compared to the other 2 plants. While on this other one, we see that the black plum tree has a high affinity for zinc accumulation compared to the ironwood and the share nut tree. So just as a summary, the transfer coefficients recorded in this study far exceeds the values reported by Alloway 1995. Generally, most plants accumulated zinc, fewer accumulated chromium, cobalt, and cadmium. But in all, no hyperaccumulator for lead was identified. This could be due to the limiting step in lead accumulation by a plant, which has been attributed to the long distance translocation from roots to shoots and its non-bioavailability. The TC values for the plants in the area decrease in this order, with calcium having the highest and aluminum the least. Zinc and cadmium have high translocation factor. This was reflected in this is a reflection of their relative poor sorption in soil. So Mendes has reported that they have poor sorption in soil, and so probably that is why we see zinc accumulation recording high. So the findings from this study shows that 18 plants were identified In all, we studied about 34 plants, and 18 plants were identified that indicated high potentials for accumulating specific metals. So standing out amongst these plants was the Heliostigma reticulatum, that is the camel foot tree, which had a TC value of 24.36, which indicates that it's able to assimilate arsenic. It's able to accumulate arsenic, and this would be of value to us if it's exploited. The West African locust bean also had a 1.21 value for accumulation of chromium. Then the African custard apple also showed potentials for accumulating nickel. Then we have the Ambromycia maritima, which showed some level of potential for accumulation of lead. Then we have the false locust, which accumulates copper, manganese, sodium, potassium, and magnesium with the various bioaccumulation factors. Then we reported also that the share nut tree was able to accumulate barite, barium, potassium, and calcium. We see the different bioaccumulation factors. Then we have black plum showing great potential for accumulation of molybdenum, while the Gardenia species showed potential for molybdenum, cobalt, zinc, and cadmium. So these were the plants that stood out for us, and you'll see some of them on the slides by this side. So these were some of the activities going on, some of the sites that were visited, and we see people having the artisanal miners on site doing their work, while this is the researcher, my humble self. So in conclusion, the results indicated that none of the plant species were identified as hyperaccumulator because all species accumulated lead, copper, zinc, nickel, cobalt, and chromium less than 1,000 milligram per kilogram. But that does not mean that they cannot be used as phytoextractors. We know that the plants also that were useful for phytoextraction of metals were identified. And as I've said in the previous slide, the West African locust bean was identified for chromium, and then the African custard apple for nickel. This I chose to emphasize because there were very few reports that have identified these as phytoextractors. So amidst all the potentials that other plants have shown, these two have barely been reported, and this research is also suggesting that the identified plants needs to be further studied so that we understand the internal mechanisms and genetic characteristics which confers on them the ability of phytoextraction of metals. This will be crucial for optimally utilizing these plants for control of soil contamination. So we also recommend that some of these plants be harnessed, thoroughly profiled, and promoted for solely phytoremediation purposes with enabling policies to support. Then there is need for public enlightenment on the dangers of exposure to high concentration of metals in these plants. Due to this should be given due attention, and as using these plants for practices such as phytomedicine and other common traditional purposes could pose great health risk. So these are some of my references. Thank you for listening.
Thank you very much, Dr. Ivona, for your presentation. We do have Dr. Elemayo from Ethiopia who's supposed to present now, but he just running a little bit late. So we may move now to Professor Ibiya.
Okay, thank you very much. Thank you. My name is Trenchard Ibia. I'm of the University of Uyo. I am the chairman of Pillar 5 of our five-year action program on on management of and sustainable development of Nigerian soils. So this is just to showcase what we are doing under the banner of our institute, the Nigerian Institute of Soil Science. The objective is to introduce the Nigerian Institute of Soil Science to community of practice and to highlight the Global Soil Partnership 5-year action plan for the sustainable development and protection of soil resources in Nigeria, and NIS, our institute, as a collaborator. We are here to showcase the update on Pillar 5, which is harmonization of methods, measurements, and indicators. Next slide, please. The objective, the background of the institute, which was established in 2017, has the mandate to regulate the practice of soil science for increased profitability to all stakeholders and guarantee improved soil management systems in Nigeria. Next slide, please. And this has core mandates to include certification and registration of soil scientists in Nigeria, discipline of soil science practitioners, laboratory regulations and accreditation, institutional accreditation, standard of practice, soil and fertilizer quality assurance and quality control, sustainable soil management, environmental quality and sustainability, and of course, research and development in soil, land, agriculture, and environment. Next slide, please. NIS works through collaboration, through cooperation and partnership. At the international level, NIS is collaborating with ISRIC, with Global Soil Partnership, USAID, UNDP, IUIS, International Fertilizer Development Center, FAO, IITA, and of course, OCP Africa. Next slide, please. At the national level, we are collaborating with the Soil Science Society of Nigeria, Agri Society of Nigeria, Nigerian Environmental Society, Standard Organization of Nigeria, Nigerian National Accreditation Service, NINAS, and one fertilizer company called Indorama Eleme Fertilizer and Chemicals in Port Harcourt. Now, coming to the five-year action plan for the sustainable management and protection of soil resources, which is the main focus of this showcase presentation. We are in tandem with Global Soil Partnership 5-year plan of action for sustainable management of soil resources. And these involve 5 pillars. Pillar 1 is promoting sustainable management of soil resources. Pillar 2 is encouraging investments, technical cooperation, policy education, and awareness awareness and extension in soil. Pillar 3 is promoting targeted soil research and development, particularly focusing on gaps and priorities and synergies with relativity to productivity, environmental and social development of actions. Pillar 4 and 5 are related. Pillar 4 is enhancing the quantity and quality of soil data and information, particularly with regards to data collection or generation, analysis, validation, reporting, monitoring, and integration with other disciplines. Next slide. Sorry, Pillar 5 is harmonization of methods, measurements of indicators. Next slide. So the objective of Pillar 5, and key priorities are to development of adaptable systems for harmonized soil characterization by building on and merging existing approaches for describing, classifying, mapping, and analyzing and interpreting soils. The second objective of Pillar 5 is improvement of compatibility or soil data whereby all global soil partnership collaborators are able to reference soil information into GSP harmonization system, which include legacy soil data and newly obtained data. Continuing with the objectives, we have number 3, development of reference systems for soil profile description, soil classification, and soil mapping. This is in line with the GSP's support for the development of new universal soil classification system. By reviewing the FAO 2006 guidelines for soil description, to develop it further as a new generic field book. The next reason for this is the application of world reference base for soil resources in referencing international soil classification. And the third reason for this development of reference systems is continuing with the application of the USDA soil taxonomy while working to achieve the new universal soil classification system. Next slide, please. The objectives continue. Number 4, reviewing existing practice for sampling, handling, processing, and preparation of samples for analysis. Number 5, objective is standards for exchange of digital soil-related data under harmonized global soil information model and vocabulary. And of course, the objective number 6 of harmonization is to review current indicator systems and evaluate procedures to harmonize criteria, baseline, and threshold data for making recommendations. Next slide, please. For this presentation, I am happy to give an update on the actualization of Pillar 5, harmonization and measurements in Nigeria. So far, we are compiling information based on the template on review components of harmonization, which GSP has identified to include soil description, starting from soil profile description, soil classification and mapping, relying on established and universally accepted systems, laboratory analysis comprising aspects of equipment, sampling, handling, and processing of samples, as well as quality assurance and control. Digital soil data and information in exchange based on soil information models, legacy data, and geographically referenced data. Soil data interpretation and application for land suitability classification, payload transfer functions, and soil quality indicators. As part of the exercise, to actualize Pillar 5 as part of the exercise, workshops shall be arranged for us to fine-tune our methods and standardize our procedures to conform to international standard of practice. We have already gotten procedural and practical manuals which are being compiled for use. We are going to undertake routine program for exchange of samples among soil and fertilizer laboratories in Nigeria. We have set up committees and panels for laboratory regulations and accreditation of laboratories in the country. And we're already having modalities for registration of soil scientists as practitioners. And we are fine-tuning the modalities. To actualize Pillar 5 and achieve the 5-year action plan, the Institute has constituted working groups based on the 5 pillars to handle the implementation of the 5-year action plan for the management and protection of soil resources in Nigeria. As part of this, the Institute has successfully developed and adopted some operational documents, as well as setting up the state-of-the-art laboratory in Nigeria. Next slide, please. The first supporting policy document or instrument is a document that is being, next slide, please. Okay, yes, this slide. A document that is at advanced stages now. There is the National Agricultural Soil Management Policy. And the broad objective of this document, which I said is at the advanced stages of drafting, the objective is to contribute to economically and environmentally viable and socially acceptable development opportunities for agricultural production in Nigeria through improved soil management practices. In view of the gaps identified in existing policies, this new policy is therefore developed to address all issues inhibiting the productivity of agricultural lands and soils in Nigeria. Continuing with the policy documents, we have a manual that is developed for accreditation of laboratories in Nigeria. And this manual is intended to guide and ensure understanding in the requirements for setting up and operating a standard soil and fertilizer laboratory in Nigeria. We also have a manual that helps us to certify and register soil scientists. NIST is implementing its mandate of registration and certification of soil scientists as professionals. And this is very important because this registration of soil scientists give capacity for implementation of the 5-year action plan and any other thing that NIST has to do for the proper management and protection of soil resources in Nigeria. Next slide, please. Like I said earlier on, as part of this, NIST has established a state-of-the-art laboratory as reference laboratory in Kaduna, northwestern state of Nigeria. The laboratory is a reference laboratory, like I've said, and shall serve as a nucleus reference laboratory for networking and exchange of soil data in and outside Nigeria. This is in line with the holistic mandate of NIST to regulate the practice of soil science for increased profitability and guarantee improved soil management system that will embrace environmental sustainability and ensure high agricultural productivity and food security in Nigeria. Next slide, please. I'd like to conclude by thanking CRO in particular and ISRIC for giving me this opportunity. The main learning objective of this presentation are to show or indicate methodologies and standard practices in Nigeria in handling soils in Nigeria, soil and land resources in Nigeria. The next learning outcome will be development of international standard of practice and showcasing of Nigerian soil policy, and to give assurance of Nigeria's capacity to participate in global soil data and information sharing and retrieval for sustainable soil management. Thank you very much for listening to me.
Thank you very much, Professor, for the very interesting presentation. It's actually something really important that we really want to facilitate the community of practice for Africa that's oriented around improving the capacity around African countries in setting up their national soil information system. And what you presented today was one section actually from the whole system, which was really nice and very much in details, of course, and it was very interesting. So thank you very much. Not sure if Dr. Alimayo, did you manage? Yes, he managed to join. I'm so glad. We had a bit of a problem with the network, and so we had to change the order of the speakers. So apologize for that. Welcome, Dr. Alimayo. Yeah.
Thank you, Kro. I'm Dr. Itayar by name.
Yeah.
And sorry for the inconvenience so far created. Okay, I'm now ready.
Yes, absolutely. Thank you very much for taking part of this event and for presenting your showcasing your latest finding of your research and research group. Thank you.
I would like to present one alternative fertilizer, that is organic fertilizer prepared from hydrolyzed urine and coffee processing wastewater and coffee pulp. And we will see the reduction in soil contamination and human health risk who consume a vegetable which is grown on different fertilizers, of course. So I will have this outline, some introductory objective, and focus on the result and discussion part, and what will be the future perspectives or the potential studies to be conducted pertaining this urine and other organic material mixed fertilizer. So as an introduction part, we know that the current perspective is the circular economy, or that means using the waste material as the waste as a raw material to manufacture the energy or fertilizer. So this waste to plant nutrients or green waste management, and as a nutrient source can be used as the waste can be used as a nutrient source. That means after processing in some way. This is because if you just observe the FAO report of 2019, you see the balance of nutrients gets decreasing year to year. For instance, for nitrogen, the scarcity was observed in 2019. For the phosphorus in 2021 and the potassium in 2022, of course, the FAO forecast is this. So if you see for Africa, the demand exceeds the supply. It was 1.06 mega in 2019 and becomes 1.20 in 2022, you see. So for instance, if you consider the case in Ethiopia, so it is the worst because almost all is imported. The chemical fertilizer in Ethiopia, all is imported. There is no industry in the country, and there is high dependency on agriculture. If you consider about 90% of the exporters, about 83% of the labor force, and 45% of the GDP depend on agriculture. And imagine only 40% of those farmers use fertilizer effectively. So we need to support this using alternative fertilizers. If we see the coffee production part, you know, Ethiopia is the origin for the coffee. It has high significant attention in the world market. We can consider totally 10.5 million tons produced worldwide, and this Africa takes the share 11% only, and Ethiopia has 5%. And coffee is known to support considerable livelihoods. For example, a study shows about 4 million smallholder farms in Ethiopia provide income for 16% of the population, implying the high socio-economic contribution. But what about the waste? There is also a great deal of waste while processing coffee, both indirect and wet system of processing. For instance, the total world solid coffee waste production is 33 million metric tons. This is only for the solid one. What about the liquid one? To produce 1 ton of coffee, there is a byproduct, that's pulp is 2.5 tons, and wastewater is 9. So when we see the chemical oxygen demand and the bioelectrical oxygen demand, you can see the figures. About 1,250 kg of chemical oxygen demand and 775 kg of BOD is there. So this is organic waste. We have that. We know the contribution of coffee for the economy, but we can also process the waste to produce fertilizer. What about urine? Urine is known to be rich in nutrients. So we need to process again mixed with another substance, because urine is rich in nitrogen. We have to search for another substance for the mixture to process, okay? So all the nutrients in the urine are found in plant available forms. That is one advantage again. So urine could be important, and of course supported by the sustainable development targets pertaining sanitation, okay, waste reduction, recycling, and safe reuse there. So what? We have now two substrates, the coffee waste and the urine. If we use hydrolyzed urine only, it has high pH, it has high salt content, and there is very low carbon to nitrogen ratio, so that it will be difficult for the microorganisms to use on this ratio. What about the coffee processing wastewater and the coffee pulp? It has the low pH, relatively low nutrient content, the high carbon to nitrogen ratio, just the opposite for the hydrolyzed urea. What if it be blended? The blending could be a solution to address the two wastes. So that will be the effect on soil and health is the purpose for this presentation, okay? So I'm coming to the objective, investigate the effect of coffee pulp, compost, and hydrolyzed urine with coffee processing wastewater. We have a wastewater from coffee pulp processing, and we have the urine. So on soil characteristics, and examine the nutrient and anti-nutrient dynamics during composting, which will not, of course, not be presented for the interest of time, okay? And just focus on the health risks if the cultivated cabbage is ingested in different time. So we had two experiments. One is a pot-based experiment, and the other is the field experiment. For the pot, completely randomized design experiment was used. And for the compost application is, again, we just have the criteria to apply based on the nutrient requirement of the cabbage we cultivated. We apply both fertilizers. We're having two control. One is the non-fertilized as a negative control, and mineral fertilizer as a positive control, depending on the need of the plant. The other is the field application. That is completely randomized block design was used for the experiments in the case, okay, as you just indicated in the figure. So standard methods were used again for soil characteristics determination, okay? So I think everybody knows the standard methods for the specific determination. For the health risk estimation, there are calculations which are used worldwide, of course. The health quotient, which is estimated daily intake or oral reference dose, okay? The daily index, the hazard index, and the cancer risk are just calculated using the formulas. So what was really obtained from the experiment? The first figure shows the result from the pot experiment, cabbage in the pot experiment, and the second in the field experiment. As you can see,
Dr. Itaya, I think we may also facing again a network problem. I think it's good to address some of the questions meanwhile until Dr. Elimai join us again. So we have the first question in the chat. First question is for Dr. Ivona. What is the final fate of the plant after phytoextraction? It's from Irimas Alayo. So, Dr. Ivona, would you like to answer this?
Okay, so for that question, thank you for the question. I would just like to suggest some possible ways of handling such plants. when plants are used for, if you watch in my recommendation, I suggested probably a framework or policies that could be set on. It's expected that if plants are being used for such purpose, it is for places that really have issues with contamination. And then if those plants are being used, it's expected that such places be barricaded and people be adequately informed on regarding usage of such plants for other alternate uses, you know. So, but aside that, there are also identifying the plants that have potential is one step, and then we could go further to identify the mechanisms by which these plants pick up this metal. For example, my results, the results I discussed was based on the bioaccumulation factors. And when you check the translocation factor, you might be able to tell if these elements are actually in the root zone or if they are translocated up to the above ground biomass. So that will give you an idea of how to deal with them. So for those in the root zone, we have other procedures that you could integrate into the phytoremediation system that could allow processes like rhizodegradation. And in that case, you combine the activities of microorganisms with with the characteristics of the plant. And in that case, the microorganisms are able to degrade the absorbed metals. So they act on those metals, maybe probably reducing them to concentrations that will not be harmful to humans or to other living organisms. So that's one of the ways you could integrate other biological processes into the phytoremediation process to make sure that both the plant and the environment does not suffer for it. So there are others. Coming from a biotechnology research institute, we also look at genetic engineering, where you have to modify the plants and modify the way the genes that are responsible for picking up these metals. So in that way, you actually modify the genes that are responsible such that it doesn't, if the biomass is more important to you, so you have to modify in that words. If it's the trunk or the other parts of the plant that are more important to you, so you have a way of redirecting the storage of these metals in the plant. So that way the plants become still useful for other activities. So in addition to trapping carbon and stabilizing the soil characteristics, you still get your soil cleaned up, and then you have a stable soil as well. So I consider it that the advantages are far beyond the possible disadvantage. So I don't know if that satisfies him. Thank you.
Thank you very much for the answer, Dr. Ivona, and I hope that was satisfied as you mentioned. So if there's extra question, please post it again in the chat. And welcome back, Doctor. Glad that you can join again.
I'm really sorry. I will
No,
just
it's
travel
fine.
by.
We just took some time to go through one question, actually, not all the questions, so it was fine. You may resume if you like your presentation again.
For the interruption again. So that means when we use the compost from the mentioned ingredients, compost increase maybe the soil pH, partly due to the primary and secondary macronutrient level of the compost. Of course, that is in partly depend on the amount of hydrolyzed urine used during compost. So the soil organic carbon and available potassium and phosphorus was significantly increased in the compost side and can be used for subsequent production without even applying more compost on that specific soil. The other problem mentioned pertaining the urine-based fertilizer is the salinity and the solidity issue. Okay, so in this study, we tried to again investigate these issues, as it can be just as it has been indicated again. There is no soil solidity, soil salinity, or salinity problems observed. You know what the criteria pertaining the electrical conductivity, the exchangeable sodium percentage, and sodium ratio. Okay, so there is no just these things are observed. The salinity may be occurred in the liquid fertilizer, that is urine-based coffee processing wastewater mixed fertilizer, if during when it is used for successive production, for successive application, this salinity may occur, but of course need more research. And the PowerPoint gets fixed and unable to move. Yeah. And now is that okay? Okay. So we know this criteria, I think. So a soil is sodic if the exchangeable sodium percentage is greater than 15%, or the ratio is greater than, the sodium ratio is greater than 13%, as you can see from these figures. So one thing which was really the objective of the study is comparing the mixture with the pure urine, because there are some recommendations to use urine as a fertilizer. Is that really effective, or what will be the effect of this urine on the soil characteristics? And we tried to compare. Okay, as you can see, the urine only. Okay, the urine, using urine only as a fertilizer will increase the exchangeable sodium, the electrical conductivity, and exchangeable sodium percentage more than the other fertilizer. That means the possibility to be a soil saline is high, especially when this fertilizer is repeated. Okay, when this fertilizer is repeated, and we can say the compost part, the compost is the safer among the other fertilizers. The other is the concentration in soil after production. So we have these anti-nutrients, the tannin to end the caffeine, the phenol, and the heavy metals, and the compost was found to increase the total phenol content of the soil after production, okay, and which was significantly different from the other treatments. So this could be due to the coffee pulp, okay, contains high amount of phenol, and the other and surprising result was the one on the cadmium, which gets increased in the mineral fertilizer, significantly different from the other. That means the mineral fertilizer we used may contain cadmium in it. I don't know, but the conclusion may be that one. And all of them are below the recommended limit by FAO and WHO recommended limits for the heavy metals. So the concentration in the plant case, okay. So the mineral fertilizer in case of the metals for the in the nickel is higher in the plant, okay, manufactured using mineral fertilizers than the other one. And for the lead, is it in the compost, the urine fertilizer, the liquid fertilizer, and the mineral fertilizer are comparable. So there is no significant change was observed among the treatments in this regard. So the concentration of metals in the cabbage is far below the FAO and the WHO. What does that mean? So is there any health risk associated with it while consuming the cabbage produced in these fertilizers? Or shows they are safe at safe level, even by far lower than the cabbage produced for the market. We tried to compare, and there are again studies. So they are below the health risk concentration. So there is a very little risk of health due to the cabbage consumption pertaining to that. Coming to the conclusion, the liquid fertilizer that is prepared from the hydrolyzed urea and coffee processing wastewater can significantly increase salinity, but has lower effect than using hydrolyzed urine alone. So still combination is better for the liquid fertilizer, and for the compost and the liquid fertilizer application, significant increase the soil organic matter, available potassium and exchangeable cations. That means it partly increases the fertility of the soil. So there is no solidity, salinity, and sodic salinity effects for single round application because the study was for the single round. Okay, so further investigation may need for repeated application. So there is no risk associated with this cabbage ingestion. So what just try to recommend for future studies is one, the microbial issue. The microbial dynamics should be investigated. Okay. The other, studies pertaining, okay, repeated application and the socio-cultural acceptance. This has to be give due attention, because as the people may say, this is urine, which is a waste material excreted from human. How we use this urine as a fertilizer. So the socio-cultural acceptance, the paradigm shift has to be worked on that. So is a repeated application already said, and minimize the soil salinity effect more if there are so many materials which are low in sodium and chloride content specifically, maybe mixed with the coffee pulp and the urine, so that it will be lower than the expected and for repeated use especially. So, and increase nutrient concentration to minimize the bulk or the mass will be used. Thank you very much for the time I have, and really sorry for the inconveniences I made and the time. Thank you very much.
Thank you very much, Doctor, for the very interesting presentation. We may take some time to go through the questions in the chat box. There's a comment from Dr. Farouk Umar. He says it's a nice idea to start thinking of alternative fertilizer, as a mineral fertilizer is become more difficult to obtain in almost all African countries. Another alternative to me is to make better use biofertilizer, also convert our refuse waste to health. We need to promote composting of waste and use as organic fertilizer. Thank you very much. And also there are a lot of comments. Yeah, we have a comment from Irmas. He says, I thank you, Professor. This is for Professor Ibea, for your expertise talk. This is to request you how we can come up with a real solution to solve the soil. Oh, this is, I think, for you, Dr. Elimayo, for solve the soil fertility problem in Africa continent. do you believe the biochar-based organic fertilizer are alternative option? If you can, we work together collaboratively by hunting research grants at Africa. Would you like to address this, Dr. Eligan?
Okay, sure. This, I just bring this just to trigger discussion for other alternative feedstocks or substrates for organic fertilizer production. It is not only the coffee pulp, it is not only the coffee processing wastewater or the harvest rain are mixed to produce organic fertilizer. As far as we have a waste material which are biodegradable, okay, we can use as organic fertilizer rather than entirely depend on importing chemical fertilizers, which are not again good for soil. Is that? So yes, of course, the biochar and other substances which are biodegradable in our surrounding, depending on our locality. If we have a sustainable source of those waste materials, they can be converted into, especially if it is in compost form, that's very good. That's very good, okay? So the main thing what we need is sustainable waste production, if that is the case. And mixing, of course, is really important after having some chemical and physical chemical analysis in lab. The materials can be combined to produce compost, and organic fertilizers can be used. Thank you.
Thank you very much. And Dr. Ivona also mentioned that it's interesting presentation, and she would like to work with you on some future aspects. So it's good that you both part of the COP, so you can easily connect. And if you need any help from our side also, so we are so happy to facilitate the connection to make it easier for your collaboration, of course. I actually have two questions for you myself. Can you tell me about what was the soil texture? I think I'm not sure if you mentioned, but if you did, then I missed it. Sorry. What was the soil texture? Did you address any soil texture in or you only worked on the cabbage? You only analyzed the cabbage.
That has already been addressed. By the way, this is part and parcel of PhD work.
Oh yeah.
And I will be glad if another presentation for the soil texture, for soil property, and what happened, the detailed procedure.
Yeah.
It will be presented there. The soil was dominantly clay, and again, it is also mixed loam part. Okay, but this was clay.
Yeah.
And I expect another presentation in those issues, of course, because you fixed the time to be 20 minutes.
Yes, actually, yes. Yeah. So you said you are expecting to be a clay, so yet to be analyzed. Is that correct? Am I getting that?
Wait, what?
Did you mention that you are expecting the soil texture to be mostly clay? Is that just expectation, or you already analyzed that?
No, already done.
Already done, and it was
I was
mostly
curious
clay.
about the organic fertilizers and
Yes, the texture of that.
Yeah.
But you don't think that it is connected? Like the soil texture affecting a lot the organic fertilizer, how much are they holding, and organic carbon also, right?
Yeah. That background information is already collected, and the fertilizer is applied based on the background information.
Yeah.
The pre-analysis was performed, and the amount of fertilizer applied on it is depending on that information. Okay.
Right. Thank you very much. And
Yeah.
I have one more question.
Okay, go ahead.
The combination you recommend for the UCP/WW plus compost.
Okay.
Is how much that cost is that affordable if you are recommending to use that as a best solution to avoid the salinity, to avoid so many problems of other fertilizer. But would that be costly, economically affordable for?
Yeah, as already been said, all are waste materials.
Yeah.
In the feedstock or substrate issue, almost there is no cost if it is performed on site. If it's just transported, maybe what is required is a transportation cost to another area. But it is better to transport the output than the raw material, I recommend. And almost there is no cost because people need the waste to be managed rather. Because, for instance, the coffee processing wastewater is mixed into a river where people are using, and it pollutes that river. And that coffee processing wastewater is again mixed into the agricultural land, dries whatever is there because the pH is very low. You know, coffee processing wastewater, the pH is around 3. Okay, so managing that part is taken as an advantage. So the cost, there is no any cost pertaining these issues. Okay.
Yeah.
Yeah.
Thank you very much. I think we have more questions in the chat. From Dr. Ivona, in my institution, we run a similar system, which we call the EcoSan technology. One of the main challenge was getting the quality needed for continuous production. And we have also another question, I guess, from Yasin. He says, interesting presentation, and he need to know the compost quantity added, also urine doses.
Okay. Nice, very nice question. For the first one, that is the relation with the ecological sanitation approach. But think of a local community with ecological sanitation, how much cost, how much of those rural area people have such facility. That is a problem in Africa. We tried to present an approach there in the local area, but due to cost and feasibility issues, it fails. Okay, so an approach, it may work for a communal level or institutional level, but for the rural society, it may not work in Africa. That is the issue. Pertaining the dose of urine and the dose of compost, it may differ from plant to plant and soil type to soil type, of course. And for our case, the dose of the compost and the dose of the urine was applied depending on the fertilizer needs of the cabbage. Okay, the fertilizer needs of the cabbage. And the optimum force stands for the urine only, the 1:3 ratio with that of water, yeah? One volume, for instance, if we take 1 liter of urine, we have to dilute it with 3 liters of water. If urine is only used. And that is not, of course, again, highly recommended because salinity again may happen after a repeated application. Okay, so the dose varies. So we need to study the requirement of that specific plant we need to use. Okay, so by the way, for this study, I need to recommend my profile in Google profile, Google Scholar profile. There are the publications, about 7 publications pertaining this issue. And for the participants, please, I recommend to go there to see the detailed data and the methodology used for such studies for detail. Thank you.
Thank you very much. Thank you very much, Doctor. And there's another question also for you from Dr. Aziz. What are the pre-treatment imposed on urine fertilizer to prevent infections from the application?
Again, a very good question. When urine is mentioned, people think of the healthy issue while using urine. As I mentioned, we used hydrolyzed urine. Hydrolyzed urine means simple storage of urine, maximize the pH up to 9. So it will be totally alkaline. Those potential microorganisms in the urine will die of ammonia toxicity. Okay, the pH reaches 9 because it is due to the production of high concentration of ammonia. So the ammonia toxicity by itself, natural, by itself kills the potential pathogens inside the urine. So hydrolyzed urine is always recommended than the fresh one to alleviate such microorganisms related or pathogens related issues in the urine. Thank you. The other may be the change in pH while mixing with, the coffee processing wastewater has oppositely acidic pH, that is pH around 3, and the urine is pH around 9. What will happen if we mix them? There is a total change in pH. So a unit change in pH will damage the microorganisms, will damage the pathogen. So we'll use 2 issues in this case. Thank you.
Thank you very much. There's a suggestion also from Yasin says, I propose that you study the impact of total polyphenols on soil microbial biomass. It's just a suggestion. So thank you very much. And hello?
Yeah, okay, I'm Hermes from Macham University. Are you hearing me?
Yes, we do.
Okay, good. Thank you very much. Yes, of course, I have asked one question for Professor Jamu, not for Dr. Itayan. So, of course, I've seen this this conference platform from the LinkedIn. So just I'm trying to attend this today's show, or let's say this meeting. So I found it is very interesting, and I hope there are very critical issues that we have to do as a group or as a collaboration. Especially there are some field expertise talk on the soil issue as an African continent, especially from the Nigerian case. We have heard the soil quality issue and how their future plans looks like. So anyway, this today's meeting was very interesting, and if there is an access, so it is better to do collaboratively as a continent. This all in my side. Thank you the time that we had.
Thank you very much for attending the event. Professor Ibiya, I had a question for you. For the interesting talk you gave, and I would like to know that the presentation you gave was you mentioned it was in a collaboration with so many organizations, including ISRIC. So I wanted to know, is this a part of a project starting soon or finished? Can you just tell us a little bit about it?
Yeah, yes. I mentioned collaboration in the sense that the Nigerian Institute of Soil Science, which is collaborating with Global Soil Partnership, also collaborates with ISRIC. As an institute, it relates with ISRIC. But the 5-year action plan for the management and protection of soil resources is a project in a way. It's a five-year project that we started last year. And what I tried to do today was also give an update of what we are doing, which is under the umbrella of the Nigeria Institute of Soil Science, the body that regulates the practice of soil science in Nigeria. So it's a project in a way, a 5-year project.
And is it only for Nigeria?
Yes,
It's
the component we are doing is for Nigeria, but it is brokered by Global Soil Partnership. So any country is free to link up with Global Soil Partnership and look at how they can look at the various pillars of the 5-year action plan for soil resources management.
very nice. Thank you very much, and wish you all the best and success. Thank you very much for all our speakers today to
Thank you.
take part of this event. We really appreciate your contribution, your time, and we wish you all the success for your future work. And we hope that this event also helped to bring in more connection for future work and more collaboration also. And we would like to see more COP members participating in different events also to build a great network and partnership and trust also for more collaboration to enhance the soil around Africa. So thank you very much for this. And I would like to ask our guests if they have a final questions before we close this event. So if not, then thank you very much for attending, and thanks for your time, and wish to see you again soon.